7.1 is nth root or nth roots and rational exponents. Not a big deal. Now, what I do want you, or what I want to ask you, is for you guys, is it challenging when they give you things in just letter form and they start, like in that green box down there on page 401? Is that confusing to you guys? Yeah? Okay, when it starts talking real nth root, n roots of a equals a 1 over n. Okay? No. Well, kind of. Okay, now, that, I agree, that gets kind of confusing. What we have to remember, okay, there's a couple things we do have to remember here. Okay, I'm not so worried about how many roots it has. We'll work our way into that. Okay? But if I have n roots of a, okay, we have to understand that that is equal to a to the power of 1 over n. What's that? Yeah, I bet it would have. Yeah, I would write that. Okay, so for example, if I have, let's say, the cubed root of 7, I can rewrite that. If I want to write that without radicals, I can rewrite that as 7 to the 1/3. Okay. Or maybe they give you 9 to the 1/5. That would be the same as what? The 5th root is how that would be pronounced. The 5th root of 9. Okay, so we can now switch between radicals and exponents if we need to. Okay. Now, other than that, there's not a ton of useful information there at the top. Okay, so let's take a look at example 1. Okay, I'm not going to go through all of that green box stuff because I agree with you that it's kind of confusing. I think I can explain it better than if you just learned all those letters. Okay, so we want to find, example 1 says find the indicated real nth root of a. Okay, n equals 3, right? Okay, so 3 is my radical, right? So I have the 3rd or the cubed root of negative 125. Now, up until this point, could you have a negative under your radical? No, and that was because we were always working with square roots, right? Okay, so a negative wasn't ever going to work out. Now, could I end up with a negative under a cubed root? Yeah, because a negative times a negative times a negative is a negative. Okay, so if you have an odd number here, this number can be negative. If it's an even number, this number cannot be negative. Okay, so what times itself 3 times gives me negative 125? Negative 5. So your answer to the cubed root of negative 125 is negative 5. You can do this in your calculator. So grab your calculators real quick if you have them. Make sure I know. Okay. In your calculator, and most of you have the TIs that I have. Okay, some of you with the Casios and graphing calculators, it's a little bit different. Okay, but if you want the cubed root of something, you type in a 3. Okay, and then it's like second caret maybe, you need to get to this button. And then negative 125. And you get what? You get negative 5. Okay, so could you do the ninth root of something? Yeah, you could do any root of a number now. Okay? Now, we need to try to get to the point where we don't need the calculator, though, because that's what our goal is. Okay, we want to be able to do most of this without a calculator. I would have expected you to probably be able to do this one without a calculator. What times itself 3 times is 125? You should know that that's 5. Okay. Now, let's do another one here. I have the 4th root of 16. So I have the 4th root of 16. So I'm asking myself, what times itself 4 times equals 16? Close. Why plus or minus? Because isn't negative 2 times negative 2 times negative 2 times negative 2 still a positive 16? Okay, so there's another rule. If it's odd, it can be negative in here. If it's even, it can't. But if it's even, well, you need a plus or minus. Right? Okay, so we're gonna. Those are the only real 2 important rules that you really have to be thinking about. What could you have rewritten this as, Spencer? 16 to the 1/4 power. Good. Which you could also type in your calculator, and it would give you 2 as well. Okay. Okay. Now, that next box, flipping the page, rational exponents. This is an important one. What's rational mean? Right. A rational number is anything you can write as a fraction. Okay, so any number that you can write as a fraction is a rational number. So it's not like pi, right? Okay, pi is not rational. Okay, so it says let a to the 1 over n be an nth root of a, and let m be a positive integer. Let's see. M. Okay, so if I have a to the m over n, I can rewrite this because I know, first of all, power of a power I multiply, right? You guys agree with that? If I have 7 cubed squared, I multiply my 2 and 3, right? Okay, so I actually have 7 to the 6th power. Okay, that's kind of what we're going to break this down into. So if I have a to the m over n, I can rewrite this as a to the 1 over n to the m. Because when I multiplied those two, wouldn't that just give me this? Okay. Now, since I have this, I should be able to rewrite that as a radical, correct? Wouldn't this be the nth root of a to what power? To the m power. Again, personally, this stuff's kind of confusing for me. I think it's easier once we actually start to get into some examples. Okay, but that's different styles of learning. Okay. The other one that we want to talk about is what if it's a to the negative m over n. Use your information that you already know. If you have a negative exponent, what do you need to do with that? You need to put it on the bottom. So this should be 1 over a to the m over n, correct? And then from there, we just do the same thing. A to the 1 over n, not 1 over 2, to the m, which then changes to 1 over the nth root of a to the m power. Okay, and we also know that if I get a radical in the denominator, I need to get it out, right? If my final answer is a radical in the denominator, we'll get it out. We'll do that a little bit later. Okay, what cannot be on the bottom? I could have a negative on the bottom. I can't have 0 though. The denominator can never be 0. So is there any scenario where this could come out 0 that would work? No, just keep that in mind. Your bottom there cannot be 0. Okay. Again, to me that stuff's a little bit confusing, but I do want to get that down in case some of you like to look back at that. Okay, I like to look at the examples. Okay, we ready? Okay. So I'm not going to do the ones out of your book. I'm going to do different ones. That way you can use the ones in your book too if you need to. I have 16 to the 5/2 power. And I have to figure out what this is. Okay? We want to do this without a calculator. Okay? So, what can I change this into?
16 to 1.
It could be 16 to the 1/2 and then raised to the 5th power. Well, I know, and maybe you don't even need to write it, 1/2 power means what? What's another way? First thing we talked about, if that's a fractional exponent, I can change it into a radical, right? Remember talking about that up here? If I had a fraction as an exponent, I could change it into a radical. So instead of 16 to the 1/2, it's actually the square root of 16, right? And now the square root, we don't write it, but the square root technically has a 2 there. That's still the square root, right? Okay, so I have the square root of 16 and then raised to the 5th power. Well, what is the square root of 16? 4, so I actually have 4 to the 5th power, which is 1024. Okay, so there's a handful of properties and rules that we're going to have to keep in mind. Okay, one of the biggest ones, or two of the biggest ones, is changing from an exponent like this into two different exponents. Okay, a rational exponent into a rational exponent and a whole number. Okay, and then knowing that you can change this rational exponent into a radical, and then we can solve from there. Okay, look, the next one, let's do 64 to the negative 2/3. Okay. Kobe, what's the first thing you would do to that? Good. Let's get rid of the negative. We don't ever want negatives. Negatives are bad. So we get that to the bottom, so I actually have 64 to the 2/3. Okay. Then what, Jack?
You want to go to the rational, or do you want to do
Whatever you would do next.
1, 3? Ask the 3 before the square root.
The cube root?
Yeah.
Okay, so some of you are going to be able to do this. Jack skipped a step, right? Is all he did. Okay, he knew that this was the same as 1 over 64 to the 1/3 squared, right? Okay, so he did that in his mind. He knew that 1/3 meant cube root. So he rewrote this instead of writing that step second. Is that okay? Yeah, you just got to be careful because is there a chance that you might mess up a little bit? Yeah, so just be very careful. I'm okay with it if you're getting it right. If you're getting it wrong, we're going to have to redo it. What is the cube root of 64? 4 squared, 16. So my answer, 1/16. Okay. Questions there? You just have to be careful is what it really comes down to. You got to be careful. Remember those few properties we talked about. Okay, I do want to look at example 3 just briefly. Okay, it's using a calculator. Could you punch this into your calculator? Okay, just be careful, please. If you do it all in one, make sure you put the parentheses around it. If you're not going to do it all in one, do the 4th root of 5, hit enter, and then raise it to the 3rd power and hit enter again. Okay, don't round it and then raise it. I would suggest just using parentheses. You got to be careful because they might put some parentheses in there as well. 3.34. Okay. All right. The last one that we need to really look at is example 4. Okay. Example 4, part A. I'm not going to do the ones they have in the book. Okay, but I have 6 x to the 4th equals 3,750. Just because I have higher exponents, does that mean my process of solving an equation that we learned in 3rd grade changes? Probably not 3rd grade, probably like 5th grade. Does it change? No, doesn't change. Okay, what's your first step? Divide by 6. So I have x to the 4th equals, what is it? 625. Okay. And now you do what? Yeah, you do the 4th root of it. You don't square root it, you 4th root it. Okay, those cancel. You take the 4th root of 625, which is probably able to do in your calculator. And what do you get? You get 5. Now, even radical. So plus or minus 5. Okay, plus or minus 5. Okay. I don't know. Maybe it's not in this lesson. At some point, you're going to have to be able to reduce a cubed root. Must not be yet, though. Okay, last one here. X plus 1 cubed equals 18. Now, this one's a little bit more advanced than just a linear equation. We have done these. How do I start to solve this? Why do I have to cube root first? Because, yeah, remember, when you're solving an equation, you're doing order of operations backwards, right? Okay, so you're doing parentheses, exponents, multiplication, division, addition, subtraction. Well, there is addition and subtraction, but it's on the outside of your parentheses, right? Or it's, on the inside. Okay, so your addition and subtraction, there's nothing outside. Is there any multiplication outside? No. Okay. So now you go to exponents, right? I got to get rid of that exponent. Okay, well, to get rid of a cube, I cubed root. Those cancel. Oops. I cubed root. What is the cubed root of 18? Do you want decimal, though? We don't want decimal. No, it isn't. 3 times 3 is 9 times 3 is 27. Is there one? No. So I'm going to leave that as the cubed root of 18 for now. Equals what's left? X plus 1. Oh, it is in this lesson. It's this problem right here. Subtract 1, right? Okay, I have x equals negative 1. Plus or minus, or just plus? Why not plus or minus? It's an odd radical, good. So plus the cubed root of 18. Now, the book doesn't show this. They actually give a decimal answer. I don't want your decimal answer. I want to reduce this. Okay? So let's take this. I have the cubed root of 18, and I want to reduce it. Now, actually, you're not going to be able to do this. Now, you got to look for what? Do you look for square roots that come out? No, now you look for cube roots that come out. So you got to rethink this. Cube roots. First one is 2 times 2 times 2 is 8. Can you divide 18 by 8? No. Okay, second one, 3 times 3 times 3 is 27. And obviously that's bigger, so does that work? No. Okay, but if you could, you'd take out a cube root. Okay, so let's think. So right now your answer is just this, right? Okay, let's think of one that would work here. I don't want to do that. 24. What perfect cube comes out of 24? 8, right? So I have the cube root of 8 times the cube root of 3, because 8 times 3 would be 24, right? What is the cube root of 8? 2. Can I do anything with the cube root of 3? So your final answer here would be 2 cube roots of 3. Okay, so just keep that in mind. You can reduce other things besides just the square root. Okay. Now again, that's kind of the introductory to this whole chapter, so we need to make sure we can do this. So we are actually going to do this for 2 days. Okay. Today, I want you to start on number... You know what, let's just work odds today. So page 404. 13 through 67 odds. No. I'm going to want you to know this stuff. Let's go 63 there. 13 through 63 odds. Some of these are going to take you just a split second, guys. They're not going to take you very long on all these.